Andhra University, 1992-1996 batch. Master of Technology in 1996, 1998 from College of Engineering in Kakinada, JNTU, Hyderabad. He did his doctorate 2002 to 2007 from JNTU, Kakinada. He's also did his bachelor in LLB from PSR Law College, Kakinada, and pursuing Ph.D. in structural engineering. His academic experience, he taught structural engineering, geotechnical engineering, and fluid mechanics at M.Tech and B.Tech level at JNTU UK, Kakinada. Academic projects, he till guided 12 M.Tech projects, 8 B.Tech projects. His number of publications more than 30. His expertise in structural design of multi-stored building, industrial structures, sports stadiums, water treatment plants, sewage treatment plants, ground improvement, soil and rock investigation, quality control testing with high-level instrumentation. He has he is a member in different associations like Concrete Institute, IGS, in National Information Center of Earthquake Engineering, and different societies. His present position is advisor to Akurdi Consultants, Kakinada. I welcome Dr. K.V. Narasimha garu to deliver his lecture on sensitivity of foundations. Welcome, sir.
Thank you, Dr. Prasad garu. My name is Dr. Narasimha. Today I am going to present my webinar lecture on the topic of sensitivity of foundations. Before going to the in-depth of the understanding of the subject, let us define the term sensitivity. In the common parlance, sensitivity is nothing but the fineness or the quality. The term sensitivity generally we come across in instrumentation point of view. Generally, for selecting any instrument, we choose a system or instrument such that it should have as much as sensitivity is. That is, it's a fineness that is the outcome that is required for us. In a similar manner, we are dealing with the structural systems. In a structural system, there is some sort of structural loading is there. Under the structural loading, we have some sort of structural response. This response can be in the form of the internal forces that is in the structural elements. These elements, once response, will have some sort of internal reactions that is in the form of a bending moment, and it can be a shear force, or it can be a torsion. Anything we are interested, that is to be required to us in a sensible manner. That is the meaning of the sensitivity with respect to the structures is concerned. Yeah, today my topic is especially dealing with the refinements of the sensitivities that is required for the design of any foundation systems are considered. Yeah, this is the one of the famous quotation I have come across that was written about 2000 BC. It reads as follows: if a builder builds a house for a man and does not make its construction firm, and the house which he has built collapses and causes the death of the owner of the house, that builder shall be put to death. This is from the Code of Hammurabi, Babylonian Sirka. The meaning of this quotation is that whenever there is a collapse is there, or any not meeting the requirements of the particular project is there, the person who is responsible for the project, he should be punished. This is something like a different theory in the law. which means that fixes the responsibility and also the importance of the structural system is considered. Once it is not built in a proper way, he should be punished. That is the importance given. In the olden days, like 2000 BC, we can see the importance of the structural systems. Next, generally we are dealing with the foundations. Once we are dealing with the foundations, the issues are low structural elements, that is the lowest parts in a structural system. It completes the load part in the structural system, buried except a few, which is nothing but generally the foundations are below the ground surface in most of the cases. There are some exceptions. These exceptions are nothing but some of the foundations can be above the ground surface or at the ground surface. The classical examples are when we are constructing a foundation like oil storage tanks. These storage tanks we generally built above the ground surface. What is the difference or sensitivity that is with respect to the foundations is considered is the failure planes that is propagating in the soil mass is different when for the surface footing when compared to a structure or the foundation system that is below the ground surface. Given least importance, generally often the foundation systems are given least importance. We think of in terms of the bearing capacity, a SBC value or the allowable bearing pressure is just sufficient to design the foundation, and the structural engineer feels that having designed for the bending moment, shear force, that is for the one-way and two-way shears, and beyond that thinking, if it is checked for developmental also, that completes the design. But is not the case. In every aspect, the foundation is to be designed properly for all the type of effects that is acting on it, at the load point of view or the response point of view. Generally, a small mistake in the foundation design, especially selecting a suitable soil design parameter, will lead to so much of mistakes in the design of foundation systems. High factor of safeties. Being soils are highly erratic in nature and also heterogeneous, and also the extent of investigation and the laboratory tests we are conducting to a accurate value, all these factors will be involved in the deriving of the factor of safeties. That is nothing but the sensitivity of design of a foundation. These factor of safeties highly influence the your safety limits. Therefore, in the case of a foundations are considered, these safeties are at a higher level when compared to a structural loading or structural material factor of safeties. Generally, the range will be in the order of 2.5 to 3, but internationally, we are adapting a factor of safeties of around 2, 1.5 to 2 for the soils also. Regarding the categorization is considered, the foundations are categorized into two categories. One is in the form of a shallow foundation, and second one is in the form of a deep foundation. Yeah, we'll see what is the categorical definition of a shallow foundation and a deep foundation. According to the Skempton, he was the first researcher who distinguished the shallow foundation and a deep foundation with respect to the ratio of the df by b, where df is nothing but your depth of the foundation and b is nothing but your width of the foundation. When df by b ratio is less than 5, Skempton classified into a shallow foundation. And when the df by b ratio is more than 5, he classified into a deep foundation. What is the main difference that exists with the df by b ratio? That is, the failure planes that was there in the soil mass will be different. In the case of a shallow foundation, when it is at the ground surface, just below the ground surface, the failure plane will extend up to the ground surface, and most of the failure planes will have a lateral spreading of up to 5b, generally 3b to the maximum of 5b, and at a depth of 1.5b to 2b is the depth variation. That is the zone of failure plane extension is considered. When compared to a deep foundation, they were generally buried much into the soil, and the failure planes also much into the deep. And the soil confinement effect that was there in the soils will have much more influence on the failure planes. And according to Madoff, he suggested that the failure planes has an influence of 3b below the bottom of the pile tip, and they were propagating up to a depth of 8b, that is above the pile tip. Therefore, the influence of the failure zones is there up to a level B in the case of a deep foundation. Thereby, the bearing capacity factors involvement, which is the governing factors for the design of any foundation system, are varying with respect to the depth of embedment. That was categorized by suggested by the different researchers that we see in the later sessions. Now, up to now, we have to understand the definition of this schematum based upon the DFP ratio. Next one is the soil confinement. Just now, I have defined the soil confinement with respect to the failure planes. This soil confinement plays always major role in design of a foundation system or the behavior of any foundation system is constructed. We know that soils will have better confinement when once we go with the depth of existence, that is stratification. The reason behind this is the modulus of elasticity, especially for the columnar soils, is much more dependent upon the depth factor. Therefore, the failure planes and the probability of the occurrence of the failure planes is entirely depends upon the your modulus of the stiffness. The stiffness governs the development of the failure planes. Therefore, soil confinement, which is a function of the modulus of elasticity of the soil, is always plays an important role on the failure planes. Regarding the coral provisions are concerned, these are mandatory we have. That is not only in India, for any country, there are certain codes of governing is there. For Indian conditions, we have different codes like 6403 and IS 1904 and IS 8009. These are the different codes we have, which governs not only the bearing capacity, the 8009 gives the settlements of the foundations, and IS 1904 also gives the your permissible limits for the settlement point of view, and IS 6403 gives the your bearing capacity development and bearing capacity evolution point of view is concerned. Regarding the deep foundations of considered, we have the governing criterion of IS 2911. That is, we have different parts. Like we have for the timber piles, we have one type of codes. For board sensitivity piles, we have one set of codes. IS 2911 Part 1 Section 2 is pertinent to board site sensitivity piles, where which are mostly we are using in the practical cases. And also for the board piles, we have different codes. For underlying piles, we have 2911 Part 3 is there. And for testing, altogether, we have a IS code of 2911 Part 4 is there. These are the code and differentiation for the design point of view is concerned. Now, when coming to the economy point of view, economy plays always an important role for designing or choosing a appropriate foundation system. Once it is economical, it is a client-friendly solution. Regarding the economic point of view is considered, generally shallow foundations are economical. As we know, the deep foundations are always the material involvement or the technology involvement or the design involvement. All the involvements that was there for the construction of a deep foundation are much more costlier. Therefore, as a costly point of view, this is generally not favoring any client requirement is considered. Therefore, we can say that shallow foundations are economical. The least construction equipment. This differentiation is nothing but in the case of a shallow foundation with the simple dewatering equipment and the shoring and sorting available in the local market, using which we can complete the task. Whereas when coming to the deep foundations, it requires a sophisticated equipment like piling rigs, and you have the requirement of this concreting, and also some sort of special pumps are required for the DMC circulation and all that. Therefore, the sophistication of the construction equipment will be also high in the case of a deep foundation when compared to a shallow foundation. Fine. As an engineer's point of view, both as a structural engineer and as a geotechnical engineer, we have to understand the failure planes that was propagating in the soil mass and the application of the loads. On the left side, you have the failure planes pertaining to a shallow foundation. On the right side, you have a failure planes pertaining to the deep foundation. First, we see the failure planes that is extending to a shallow foundation. There are various bearing capacity theories that was available in the history way back from Rankine Spanglets to modern day Terjigi, Mayroffs, and Rich Hansen. We have Skelton equations are there. All these equations are the refinement over one over the other. The first research that was systematically conducted by Carl von Tejge in 1940s, that is in 1948. He conducted some model tests in a test tank of specs using a straight footing, that is a rigid rough footing he has considered as a surface footing without the effects of the water table. What he had considered is he had he had prepared a model tank with a dense sand, and in the dense sand he has modeled, that is, he has put a rigid footing on the top of the surface, and he loaded up to the failure such that the slip footing which has undergone the general shear failure, criterion type of failure, and he observed the various failure patterns. That failure patterns is nothing but what we are seeing in this lecture, that is on the left side figure. In this, he proposed three zones. Zone 1, that is the central zone, and there is a zone 2, that is the intermediate zone that is coming in the middle, and there is a zone 3, that is the passive zone here. In the case of elastic zone, this elastic zone is nothing but which is a zone that is adhering to the bottom of the footing, and it makes an angle of 5 degrees with the horizontal plane, that is the horizontal surface. And this elastic zones, which moves along with the bottom of the footing, and which will try to push the zone 2 in the lateral direction. Once it is pushing the zone 1, that is elastic zone in the zone 2, there is a development of radial shear zones that is along this logarithmic plane. This is the logarithmic plane that is expected in the zone 2. This zone 2 soil is mostly responsible for the shear stress or shear resistance point of view. And he proposed also a third zone, that is the passive zone, that is lying near the ground surface, which is close to the ground surface. But the movements of the shear displacements are not significant in the zone 3 that was suggested by the tertiary. And zone 3 is making an angle of 45 minus pi by 2. This is the horizontal angle that is making with the zone 3 failure plane. These three planes are very important for the contribution of the shear resistance against the applied generated shear stresses that is generated to the external loading. There is an equilibrium of forces he has considered on this elastic wedge. This elastic wedge, on the elastic wedge, you have the passive forces that is due to the contribution of cosinus of the soil, and also the depth factor, and also the that is represented in the equivalent surcharge in the Tejge's equation, and also that is due to the the depth factor and the cohesion PC, PQ, and P gamma, and that is due to the unit weight also. Therefore, he considering the superposition of all these three passive resistance, he formulated the bearing capacity equations, and he suggested for the bearing capacity for the general shear case. He extended his work for the local shear also by modifying the shear parameters, that is a cohesion value equals to C prime, that is equal to 2/3 of C, and a modified phi value that is equivalent to a phi prime is equals to tan inverse of 2/5. This is the conditions pertaining to a local shear variable. This understanding of the failure planes is important to understand the sensitivity behavior of the soil is concerned. According to Skeleton, a shallow foundation NC has a value of 5 plus 2. This is also originally proposed by Pandlets. Is that the NC value is nothing but 5 plus 2, that is 3.14 plus 2, that comes to be 5.4. And N cube and gamma also exists. That is, with increase of 5, this N cube and gamma also increases up to a significant value, but initial values of pi equals to 0, N cube and gamma are marginal values. The significant is 5.14, that is the bearing capacity factor with respect to any clay is considered. When coming to the previous slide. When coming to the bearing capacity factors that was proposed by Skempton, in the case of a deep foundation, first we see the what are the failure planes that we have. When coming to the failure planes that was generated in the file, just now we have discussed that the failure planes has an influence of up to a depth of 11B. This was suggested by Mayrov in his piles research work, and he suggested 3B below there is a zone of influence is there, and also the depth of 8B above the that is above the pile tip. We have two zones are there. One is elastic zone, and the second one is a plastic zone. And the extent of the shear planes that is in a pile is considered is much more in the case of a pile is considered compared to shallow foundation. The contribution of the passive resistance along these shear planes is the criterion that was adopted by the Meyer. Regarding the IS code is considered, IS code we have 2911 part 1 section 2 is there for board piles, which is based upon the DB's work. DB also has a similar sort of failure plans, but that will extend to a somewhat higher depth towards the ground surface. The IS code method is especially based upon the DB's method. In the case of a deep foundation, the N gamma value is insignificant. If it is a sands, the NQ gamma is a significant factor which governs the bearing capacity. In the case of clay soils, this NC value is much more higher because the wide spread of the failure planes, that is, comes to be near about 9. And one more differentiation sensitivity we have to understand is the bearing capacity factors for the case of a deep and a large diameter pipe, say more than 600 mm diameter, we have a slight reduction of this NC value is there. This is as per the some international research is there. I'm not going into that much of that, but it's also a function of the diameter of the piles also, NC value. And NQ value is significant in the case of sands. Generally, that will be in the range of 32 to 40 once we interpret from the angle of shearing resistance of value that can be obtained from the IS 2911 section. Regarding the performance requirements of considered, we have to consider the soil behavior in terms of the two factors. One is the form of shear failure, and second one is the form of a settlement failure. A shear failure is nothing but a load increment is there, foundation system. Under the increment of the load, there is a development of the shear stress by the it's a triaxial state of stress in most of the cases. In some cases, it can be a uniaxial state of stress also. Above this triaxial shear state of stress, there is a development of the shear stresses. Once which causes the shear capacity, there is a shear failure in the soil mass, which governs the bearing capacity, that is the strength of the soil, which is nothing but the shear failure or the shear stress behavior of the soil. That strength, which is nothing but the failure corresponding to a shear failure, or the strength is nothing but the shear strength of the soil. That in terms we represent as a safe bearing capacity. And there are various bearing capacities are there, like from 1948 Terji work and 1973 Meirov work. And again, Meirov's 1973 and Hanna work is there in 1976. Basic work was there in 1963, and Brinch-Hans's work is there, which incorporates all the factors taken into consideration. Once we look into the sensitivity of the Terji's equation, the Terji proposed a generalized case for the sands, that is especially for the dense sand subjected to a general shear failure condition and extended to the local shear failure conditions. But the exact values are bearing capacities proposed by Terji are pertaining to the general shear failure conditions. Nowadays also, in like the 21st century also, we can safely adopt the values suggested by Terji. Regarding the way of bearing capacity is considered, this is one of the practical applications, especially for Kakinada also. We have proposed the bearing capacity factors for the punching shear failure, that is especially pertains to a layered soil system where there is a strong soil underlain by a weak soil, like we have Kakinada, typical profiles are there, like top layer sands are there, followed by a soft layers are there. These are the two-layered soil system. For the two-layered soil system, what Meirov proposed is, he proposed a punching shear failure criterion, and also he suggested the punching shear coefficients, which are highly helpful for the design of any foundation system is considered. And basic method is again 1963 work. The beauty of the basic work is he considered all the three type of shear failures. That is ranging from general shear failure criterion to punching shear failure criterion. He has considered three modes of failure, and he suggested the bearing capacities for the three modes of failure. One more important aspect of basics theory is he proposed the all the other influencing factor like the depth of the factor, the shape factor, that is whether it says circular footing or square footing or rectangle footing, whatever the type of footing and its load inclination value, that is say whether it's a combination of the axial loads combined with the movements, all that is in terms of represented in the form of a inclination factor and also the depth factor. As previously we discussed, this depth plays an important role that should be think of in terms of not only the shear failure pattern, also settlement point of view. Also, we have to think of what is the depth of the formation. Basic consider all these factors and we proposed the bearing capacity factors. Our Winch-Hansel method is the refinement of all the above three methods, and he considered the bearing capacities required all the practical conditions. The IS code, that is IS 6403, is based upon the Winch-Hansen's bearing capacity theory. That what we have reflected in IS 6403 settlement. Yeah, we have a just now we have discussed this soil axial state of stress. It can be uniaxial state of stress similar to concrete is considered. Especially being these are the highly lateral strain materials that is having high Poisson's ratio. The Poisson's ratio can be as high as a 0.5 in the case of a very soft clay. Therefore, whenever there is a load increment is there or stress increment in the soil, not only before going to the shear failure, it is subjected to large volumetric and lateral and also the longitudinal displacement. That is a strain. This strain will be reflected in the form of the corresponding settlement, that is the visual phenomenon. The strain dependent behavior is much more important in the case of a soils is considered. Generally, in the case of concrete is considered, our strains will be not more than 0.35% or 0.4%. And in the case of some very low grade materials, we have 0.5% to the maximum extent. In the case of the soil behavior is considered, the sensitivity is such that it ranges from 2 to 15 to 20%. This much of large strain variation is there. Once we look at into the case of a dense sand, very stiff clays to hard clays, the strain, the failure strains will be in the range of 1.5 to 2%, not more than 2.5%. Once we reach a strain value of 2.5%, that immediately reflects in the shear failure. In the other words, to the extreme case, we have the soft clays are there. These soft clays are highly strain dependent. There is a not well-defined failure price, and the failure is generally in the form of large displacement. There is large strains in the order of 50 to 20%. Once we look at it, the laboratory model uses the test that clearly reflects the failure plane that is in the form of a bulging of the specimen that is during the testing. Yeah, just now we have discussed that this has both influence of the longitudinal lateral strains, and there is some sort of volumetric dilation is there. The dilation is nothing but this is the volumetric changes that was taking place in the case of coastal ice soils like sands. Once we loaded, there is a development of the vertical strains also, not only the lateral strains. There is a development of the vertical strains. These vertical in the form of a volumetric strain, that is a little bit a volumetric dilation that is significant in the case of a coastal soil mass like sands. The settlements is to be predicted to a much more sensitive value, yes, suggested by the different others we have, like Boussic equations are there, like Newmark's equations are there. We have Westergaard's equations are there, and Scammerdman, Buckminster, Fox, etc. All these are patterned into a different types of loadings and for different patterns of thinking of research. That is, Boussic suggested for the point load with a depth of variation of the radial direction of R and with a depth of Z direction in the vertical semi-infinite medium. He considered the equation, and Newmark's is based upon the in the form of a charts. These Newmark charts are based upon the influence diagrams, using which we can find out what is the stress increment that is coming due to the applied loads. Using that stress increment, and a corresponding strain is there. The strain is nothing but your settlement. Settlement is to be computed accordingly. Regarding Westergaard and Buckminster's equation is considered, these are pertaining to a layered soil system. That is generally Westergaard's method we are using for the, or even Buckminster method is we are using for the design of payment stresses, that is especially the rigid payments. Scammerdman method, this is there. This Scammerdman method is also for finding the your increase in the lateral stresses and also the what is the stress increment in the soil mass that is considered. regarding the Fox approach is considered, he proposed a depth factor for the depth of embedment of the footing is considered. We have different types of loading. This is also to be understood by the sensitivity of the fineness of the foundation analysis is considered. Generally, the loads will be in the form of a static loads or a dynamic loads. For the soil point of view, we have two types of loads. That is a dynamic loads. Again, dynamic loads will be again categorized into two categories. One is in the form of for the mission foundation, or second one is the form of the soil behavior subjected to a dynamic loading in the form of a earthquake or the short duration window like gust windows. And there are three force components and three moment components. That is, in a modern day sophisticated FEM software, we are considered the 6 degrees of freedom for the analysis point of view and also for the design point of view. These 6 degrees of freedom will induce 6 types of forces. That is 3 force components and 3 movement components. That was reflected in the figure here. One more factor that is to be considered is in the case of a design of any foundation system is generally we design for the axial loads, ignoring the moment effect and the shear force effects. That is not a practical case, also the sensitive case. In the case of an accurate design of any foundation is considered, we have to consider all the 6 degrees of freedom into an equivalent system such that it's a combination of the vertical load and the movement that is acting on it. Especially, this is very important while designing a biaxial loaded footing that comes across during the design of any bridge foundation is considered or during the earthquake loading is considered. And these forces are also important. All the 6 degrees of freedom forces are important while designing the design of any mission foundation is considered. Generally, what we do is we consider the axial force and the shear forces in the two directions will be converted into equivalent movements. And the equivalent movements is nothing but the shear that is acting at the top of the pedestal will be converted into the equivalent movement at the bottom of the footing or the top of PCC where you are transmitting the stresses. To that level, we convert into axial force and equivalent movement. Under the combination of this biaxial state of stress, that is P by A plus or minus M by Z, that M by Z can be further defined for the biaxial state of stresses Mx by Z axis or plus or minus My by Z by. Therefore, we have a state of stress. It is designing of the algorithm, but also for the if the movements are significant, for any case also this plays an important. That is the sensitivity required for the design of any loading is considered. And one more important point of view is even though we are converting into a joint equivalent loading system, the shear force will not be absent. Once we design for the earthquake point of view, that is especially for the piles design, this shear force again will be transmitted to the piles in the form of a column shear, similar to column shears. The piles will be also subject to shear force. It has an equivalent effect of the movement. At the same time, at the top of the piles, the piles should be checked for the shear stresses that was generated in the shear force at the pedestal level or the footing node level. Yeah, fine. We have different failure types of them. The understanding of the failure theories are also important. Whether this is very important, why? Because before analyzing any foundation, we have to assess based upon the soil investigation report. What is the probable type of the soil failure that is taking place for a particular site is concerned. Once you understand precisely this failure criterion, you are master in that foundation engineering point of view is concerned. That is nothing but you can control your soil without having any shear failure in the soil mass. For this, these are the standard failure patterns. There are 3 types of patterns. One is in the form of general shear failure. Second one is the form of local shear failure. And third one is in the form of a punching shear failure. In the case of a general shear failure, I'll go to the next slide. We'll have some clarity. Yeah. This is the schematic that shows the 3 modes of failure. First one is the figure A shows that it's a general shear failure. You have the general shear failure that was according to the theory. In that, the load settlement plot is like this. This load settlement plot will be like this. You have a clear-cut, well-defined shear point or the failure point, and you have some elastic behavior is there up to this, and beyond that there is plastic behavior is there, beyond which there is a plastic behavior is there. The distinction between the elastic plastic and the plastic equilibrium or the stressors is nothing but your failure zone or the yield zone. That can be obtained by plotting a log-log plot for the load settlement plan. Therefore, the understanding of the load settlement plan or the sensitivity of the load settlement plan is much more important in the case of a general shear failure. Again, you have three zones like this: elastic zone, zone 1, elastic zone after that, you have the radial shear zone. This is zone 2, and this is the zone 3. There is a passive zone here. And you have the heaving like this. It can be visualized from the ground surface in the event of failure. That can be visualized by any structural geotechnical engineer who was interested to. In the case of a general shear failure, the heaving is clearly and visible with the naked eyes. And the figure B shows that it's corresponding to a local shear failure criterion. The local shear failure, the failure surface settlement is not well defined. There is some sort of clear-cut change in the elastoplastic behavior to plastic behavior, and also we can obtain using a log-log plot. But somewhat extra care or judgment is required to establish the yield point with respect to a local shear failure criterion is considered. And when coming to the punching shear failure is considered, it's nothing but simply under the increment of the stress, you have simply the foundation goes into the soils. Generally, this condition is more particularly taking place in a layered soil deposits where sand resting underlined by any soft layer, very soft layer, or in the case of if the footing is directly resting on any soft layers. In that case, we can expect a punching shear failure. And in the case of a local shear failure, the probable occurrences are nothing but the medium dense sands like medium dense silts or medium dense silky sands, medium stick clays, all these soils will come under a condition of local shear failure. And regarding the general shear failure conditions considered, like dense sands, very stiff clays, and hard clays, these are comes under the your failure condition of general shear failure condition. The understanding of the failure modes or failure conditions are important not only to assess your bearing capacity by conducting suitable field tests like any plate load test or any borehole plate load test, using which we can establish the in situ values of your modes of failure, and also the behavioral understanding of the soil in the elastic manner. And regarding the punching shear failure is considered, the punching shear failure, how we define the punching failure criterion is, even though it is not evident from the load settlement plot is, we generally plot the load settlement curve, and from the load settlement curve up to certain increments, that is delta Q by delta S values, we'll find out at different intervals. If the delta Q by delta S, that is the tangent value, this comes to be a linear value not varying, that seems to be it's a punching shear failure. We come across the practical examples also in the later session. Yeah. Regarding this shear failure criterion, various shear failures were suggested by different researchers, like Church's approach is pertaining to a general shear failure criterion, and the basic approach is pertaining to the local shear failure criterion, and the punching shear failure is accordingly Meirav approach. This Meirav approach is the latest approach, that is in 1973. He has conducted for not only for the axial loaded footing, also for the axial load footing with some eccentricity. And by combining with the co-author of Hanna in 1976 work, he proposed a much more refined analysis that is having more practical value. Just now I explained this probability of occurrence. Regarding the angular shearing resistance is considered, generally we think of in terms of the soil design parameters. We think of phi value. This angular shearing resistance is more than 32. The probability will be general shear failure. Once phi value is less than 28, it's a local shear failure. In the case of soft layer, it's only the 100 quotient that counts the failure point. Yeah, the actual plots are based upon according to the works of the basic in 1963 work. Yeah. For the Kakinada soil characteristic conditions, like we are interested in a local point of view, like this is also a local center. generally where our practice is there, we generally limit our thinking and research to a local content. That's why I'm proposing here. And here there are two categories are there. One is in the form of a soil medium is entirely homogeneous, or it can be stratified soils also. In the case of alluvial soils, marine alluvium, there was both alluvium, like Kakinada coast and other coastal areas. We have a stratification is there. We have to consider our the bearing capacity series, your settlements also with respect to the stratified soil deposits. Once we look at the various borelogs which was done by us and other people like Sundar and all that, we have some tough conclusion like that. What is the actual general characteristics of the Kakinada soils are considered? That is important to understand whenever the structure is coming at a particular location. That gives some sort of, first of all, in our mind, what is the probable type of soil without doing the soil investigation. So, for all the coordinates also, I am suggesting that we should have some general idea regarding the what is the stratification, approximate probable stratification at a particular zone where the structure is coming. We can design any type of foundation with the modern technology, that is not an issue. But to understand, have a preliminary view, we require some understanding of the stratification. Right, for this, as per our experience and also for the experience based upon Sundar, it is found that the Kakinada, especially, we have a typical 2 to 3 types of soil systems are there. These systems are nothing but we have entire sand zone that is in the form of silty sand or fine sand that is extending from 8 to 9 meters. That can be there up to 11 meters also. It is central belt. That is central belt is nothing but from the Cinema Road area to the Devalaya Street area. We consider this as a central belt. This central belt area, we have the typical 9 to 10 meters of sand belt is there. That sand belt is nothing but sand zone is there. That will be sufficient to consider our structures up to 8 stories or 9 stories. With the sand is at least a medium dense sand, we are assured that the foundation is safe with respect to the shallow foundation. And regarding the other donation is there, that is towards the beach road and towards the walk road. That is beyond the Balaji Cherum area. We have different stratifications there. That is a two-layered soil system. We have up to 6 meters spine sands are there. Beyond that, we have soft clay is there underlined by the sand underlined by the soft clay. And similar profile is also there, like areas like Nagar and other areas like Krishna Nagar. All these areas we have the stratified soils like in the form of a two-layered soil system up to 5.5 or 4.5 in some cases also. There is sand zone is there that is medium dense to dense. And again, you have the followed by that is underlined by a very soft clay to soft clay. The typicality is there at some of the locations, like at Beach Road, you have the occurrence of the soft clay at the ground level itself, that is near Kumbab Sheikh area. We have directly as a encounter of very soft place to soft place out there. Like almost one more typicality is there with respect to Lakshmi Nagar area of the Godarigunta area. And regarding the applicability of the bearing capacity equations are considered, we just now discussed the 3 modes of failure. We have to understand based upon the soil stratification also. In the case of a Kakinada soils where medium dense sands are there, for the homogeneous soil, say we have 8 meters of depth of sand zone is there, stratified, a uniform stratified soil, and in that we are proposing one foundation. And as per the soil investigation report, we encountered with a medium dense sand. And what is the probable bearing capacity? Whether it is a general shear failure criterion or a local shear failure criterion. It is not the both of these two. We have a mixed state of shear criterion that is in the form of a mixed state of local shear and general shear failure that governs the failure criterion. That for that we have the bearing capacities proposed by Peck work that Peck works bearing capacities pertaining to your case of the mixed state of local shear and general shear conditions is to be applied. Why I am emphasizing this soil stratification depends upon the soil stratification. You have to select the appropriate bearing capacities. Then only your the geotechnical investigation report or the SBC or the SBP, what we are saying, finally we are saying in terms of the allowable bearing pressure, that has a significance and the reality or the sensitivity we can call it as. Why? Because once you are adapting a different non-wrong, some wrong approach of your adapting of bearing capacity factors, that leads to entirely a different solution, which is not practical and is not real also. When compared to a certified soils, these are the soils we can consider it as the soils which is much beyond the central belt of the main road area, and this is towards the beach road, other towards the wharf road we have. And for this case, the bearing capacity approach, that is the evolutionary approach, is entirely different. We have to adopt a made-up equation for the case of a two-layered soil system or the three-layered soil system. And I'll discuss this in detail in the further ongoing sessions. And up to now, please understand that the approach is different. That is entirely based upon the Mayer's approach, that is pertaining to punching shear failure. That is, the punching shear is the mode of the failure. Accordingly, whether this is a layered soil, we have to directly apply the punching shear coefficients for the sand underlain by soft clay, or you can directly, if it is a soft clay like fields existing at the Turangi areas or Madland areas, Kakinada seacoast areas, in that there is a probability of foundation resting on the soft clay. You have to directly estimate the bearing capacity factors pertaining to the punching shear mode of failure. Yeah. Before going into the further, we require some sort of understanding of the allowable bearing pressure value. As you know, as of engineers, this is a simple theory we have, but a little bit understanding is required before going into depth into the subject. This is nothing but we have two bearing capacity values and bearing pressure values are there. This is nothing but one is bearing capacity, that is a safe bearing capacity, is pertaining to a strength criterion, and safe bearing pressure is nothing but corresponding to a strain based criterion. That is a settlement dependent parameter. Satisfying these two, we have to judge what is the bearing pressure we are allowing on the soil mass or the depth of the foundation, which can safely transmit the stresses to the soils to complete its load path. Therefore, we have to think of in terms of the safe bearing capacity, that is the criterion with respect to the shear stress not being exceeded by the shear resistance of the soil. And safe bearing pressure is nothing but as we discussed just now, the soils are highly strain dependent, and the application of the stress, it undergoes large amount of not only the lateral strains, it also undergoes large amount of longitudinal strains. These longitudinal strains will be reflected in terms of the total settlements of the structure that can be visualized from the structure itself. Therefore, the same bearing pressure is pertains to a settlement criterion. Once it is not crossing beyond a permissible settlement as is by the code or any standard literature, it is safe against the safe bearing pressure point of view. That is nothing but settlements are not excessive and they are permissible, and bearing capacity is nothing but there is no strength failure is there. In the case of governing criterion is there. Yeah, regarding the governing criterion is there. We have to estimate the even though settlement is not the problem, for even the case of sands also, we have to calculate both the values. That is, we have a different tech approaches there, and like we have other approaches are there for finding the safe bearing capacity, and also for the safe bearing pressure values. These values are to be estimated even for the sands also. That is the sensitivity required. Generally, we think of that sand, there is not problem with the bearing capacity, but it's not the case. In the case of a medium dense soils like in Kakinada, where we encountered some sort of bearing capacity failures also in the sands also. Being some areas like Jagannathpuram Sivalayam area also, we have loose sands. These loose sands will have a problem with the settlements. And in areas, some areas like Kondaipalam, the ongoing bridge, that is the RLB bridge, fiber bridge going on, there is we have loose sands are there. And that is especially due to the chill for the area and the soil stratification due to the marine alluvium. We have expected some sort of settlement problem in the case of sands also. And there are some cases and some places in the Kakinada also, we have a problem with the shear strength point of view also. Why? Because we are not getting any generalized shear failure as we are thinking of. The failure mode is generally in between the local shear failure, or it can be in the form of a mixed state to a local shear failure of local shear to general shear failure. That is the general governing criterion. Whereas when compared to a layered soil is there, we have to opt for the made-up theory. And in Kakinada soils, generally, most of the cases, maximum extent is with the layered soils. Therefore, your made-up theory is adopted. Standard penetration test. This is main important design parameter generally we mostly rely upon for the design of any foundation system as a soil design parameter. That is, we have in Indian practice we have either the collection of unrestricted sampling is there, and otherwise in a collection soils we have a practice of entirely depending on the SPT value that simply we call it as M value. That is the most favorite value to the both for the structural and geotechnical units. Actually, the basic development is from the US, and in science it is extremely useful where other tests are having their own merits and demerits, and therefore a worldwide applicability is considered. The world entirely depends upon the experience value for the design of any foundation system, which is entirely based upon the N values. There are so many correlations are there throughout the world by various researchers, and these are extremely helpful for the determination of the your shear strength of the soil. What does the SPT value gives is it gives only the shear resistance, that is in an approximate way. There will not be any technical sanctity. It was something like an empirical method or something like a crude method. Driving the spoon into the soil, the distance of by the soil against the two inner surfaces. Sorry, there is the inner surface and the outer surface, and the shear resistance mobilized along the inner surface and the outer surface of the overall perimeter of the split spoon. That is nothing but your shear resistance. But why it has become so much of significance? The world has entirely relied upon its correlations. That is, they have developed so many correlations, and that till date, even though there are sophisticated equipment like a static penetration test and the dicrometer test, these are the much more sophisticated methods. The SPT test is not much updated. That is what I mean. What I mean to say. And regarding the applicability in the clay is considered, generally, truly speaking, this N value has no significance in the case of Cu value. For the collinear soils, it is dependent, and for the collinear soils, it should be, sorry, for the cozy soils, it should be entirely dependent upon the undisturbed sampling by conducting any suitable tracks and shear test or the usage test. What is the test we have? Sophisticated test that is to be relied upon. And what is the other alternative of using this test is we can have some approximate value of the Cu value based upon the N value. That approximate correlation developed by the various researchers is about 6.2 to 6.5 N. That is the Cu value, underlying quotient value. That once we check it in most of the practical cases, it tallies for the Kakinada case also. We found that based upon so many boreholes, we found that the 6.2 to 6.5 N value, that is corresponding to a Cu value, that is compared with that axial test or usage value, that correlates and matches with the Cu value suggested by various researchers for Kakinada case. For the UD samples, it is the only way upon, and the SPT should not be dependent upon for the case of a cozy soils, that is a sensitivity we require. And modern day of using field practices, we are heavily dependent on the SPT value for the clays also. It is not correct. Yeah. Before going to the before going to the what are the corrections that is to be applied, generally we know that there are two corrections. I'm not going to the depth now. We'll go on later session. Now, first of all, understand the simple test, that is the SPT test we have. Everyone we feels that SPT is a simple test. We go to the site and we simply observe the this 15 centimeters penetration and number of blows. That simplifies the test. We feel like that. Why? Because our understanding was we are confined to that level of understanding only. But the sensitivity required is not sufficient to understand the SPT N value. That we are discussing now. Yeah, we have all of us know this SPT is nothing but a driving of a split spoon with standard dimensions as per IS 2131, and we have a driving equipment that is in the form of a wire rope fixed on a tripod, and the driving force is given with the help of a cat head, that is operated manually or using a cat head of a rotary delivery or simply by using a winch. This is the driving mechanism, that is the pull that is given to the wire rope is through the systems. And we have a simple guiding mechanism is there for the end wheel. And also we have a falling weight is there. This what the falling weight does is, the falling weight has a standard mass. That is initially at the research stage, it was standard as a 63.5 mm. Now it was codified into 65 kgs. And the height of fall initially, as per the US suggestions, research work, it was 760 mm. Later it was that is 2.5 feet. And now it was standardized to 750 mm. Therefore, the parameters that mainly involves is the weight of the hammer, that is 65 kgs, and the fall height is 750 mm. That gives an impact energy, that is in the form of potential energy to the end wheel. This end wheel is nothing but this part. This end wheel is transmitting to the drill bars that was connected. Again, the drill bars was in turn connected with the split spoon that was there, which is going to be test the soil specimen. That is our point of interest. For the movement of the this mass, we have some guiding mechanism like the wheel is there to take care the this potential energy, and we have guiding rod is there that guides the verticality of the and the height of fall of the monkey, or we call it as a standard weight. And there is a drill rods are there. These drill rods are also specified by the codes. Please note that everything in the SPD test has a standard value and standard procedure. Unless and until we follow the standard procedure and standard values, the N values obtained from the field is highly erratic, and there is no significance of uses in the our as a design soil parameter. Please note it down. And we have a drill rods are there. These drill rods are having also some specifications like from the DCDMA standards. These DCDMA standards are nothing but US standards that pertains to a rotary drilling equipment. That full form is Diamond Core Drilling Manufacturers Association. These are the guidelines for the rotary drilling point of view or any drilling point of view. These are the worldwide standards we have. Like they've suggested that A rods should be used. And another alternative is AW rods should be used. What is A rods and AW rods? We see. We have standard A rods has this endless pipes with thick pipes for compared to ordinary pipes. And these pipes will have certain inner diameter and outer diameter.
Make this one.
So a slide mentioned continuous.
A slide.
Yeah, we have A rods and AW rods. This has a specific inside diameter and outside diameter. That is something like ONGC drill rods having very thick dimensions. What is the significance of this drill rods we have to think of? Or the sensitivity of these drill rods we have to think of? The sensitivity is nothing but we are transmitting some sort of potential energy to the end wheel. This end wheel again transmitting the your potential energy in the form of this N wheel is again transmitting the kinetic energy, some potential energy of the N wheel to the in the form of kinetic energy to the drill bars. These drill bars will have some sort of buckling effect if they are not standard. And the energy that was imparted to the drill bars or finally to the split spoon will not be complete, and some amount of energy will be lost due to the buckling of these drill bars. Therefore, the usage of the sensitivity of the drill bars also plays an important role. And regarding the standard test conditions are considered, we measure the penetration increments in 3 increments. That is with a pushing up for the penetration of 150 mm in 3 equivalent increments. For the first 150 mm, we discard treating as it's a sitting blow. And the second and third 150 mm penetrations are considered N value. If there is any difference is there, what is the corresponding penetration and the differential N value will be referred to in the report. And regarding the split spoon is considered, we have a split spoons are there. like this spoon having a bottom shoe with a 1 inch to 2 inch shoe length, and a open split barrel is there with a 450 length, that is to accommodate this 450 penetration. At the top, we have the ball and check valve is there. That ball valve or check valve is to maintain the to retain the sample that is in the split barrel that was collected. Especially in the case of sands below the water table, there is always slippage of the soil that was collected in the core barrel. Again, we have two models are there. These two models are nothing but there's a SPT equipment that is SPT split shoe with a inside liner and an outside liner. In the present day situations, we are not using the liner system because it is leading to some sort of errors in N values. Therefore, we are directly using this split barrel without liner. There are also some standard dimensions as per IS-Q1. One is the outside diameter as per the original research is 2 inches, that is 50.8 As per IS-Q1, it was rounded to 51 And again, the inside diameter is 1.5 inch. That was as per the IS, it was rounded to without liner, that is 38 If it is, without the liner, it is 35 and with liner, it is 30 after putting the liner, it should be only 35 The liner, there is some sort of disturbance like sampling entering into the liner of the phase. These problems is giving some sort of errors that was found as per the research. Therefore, we are not in today's practice, we are not using this SPT spoons without liners. And one more important point is to observe is most of the drilling contractors are using the locally manufactured the split barrels, and that is not meeting the standard requirements of IS 2131. This is sensitivity also be checked before using the SPT split barrel. One more important and the utmost important, as we are missing in the Indian conditions, is energy ratio. The concept of SPT test is it is transmitting the potential energy to the drill bars in the form of a kinetic energy. This kinetic energy is trying to push the that is a split spoon that is pushing into the soil. And the distance around the shear resistance around the something like a skin friction resistance over the pile, it is the resistance of the soil that is along the inner and outer edge of the split barrel that gives the N value. That is the actual shear resistance of the N value. What we are reporting or what we are observing is. For this, the main variation will come from this energy ratio. That is, what is the potential energy we are imparting to the N will be part of that will be transmitted to the kinetic energy. That energy is to be standardized. Once the code and the standard procedures were standardized, we have to follow the N value corresponding to that standardized energy only. Otherwise, what is the N values you are getting? Those are highly misleading and non-correct values that will lead to non-correct and a wrong design, we can say a wrong design of the foundation system that leads to a wrong structural response once we consider the soil structural response is considered. Yeah, as per the N values are considered, the standard equipment like height of fall of 750 and weight of 65 kgs is corresponding to an energy corresponding to 60%. That we generally represent in terms of N60 value. Once I represent N60 value, it's a universal standard application like ISO. Yes, ISO codes are nothing but it has a universal application. Similar to that N60 I reported, that parameter can be used anywhere in the board, not only by me, not only by Sundara Gadu, but not only by any consulting engineers from our group, from yes. Anyone in the board can use that N60 value from anywhere in the board for designing larger foundation system. That is the significance of N60. We see that various standardization of the energy values or the energy ratios. Yeah. Before going to the energy ratios, I will discuss what are the probable variations that the N value reported will be subject to variations. As we know, we are using some drilling equipment. Using that drilling equipment, we are doing the drilling up to a test depth, and after reaching the test depth, we are fixing the SPT spoon and we are fixing the drill rods, and after fixing that, we are fixing again this entire the falling mechanism and all that. We are using some sort of pulling mechanism, and using that pulling mechanism, we are conducting by dropping certain weight from certain height as specified code. In this, These procedures are prone to so many variations, like this is a entire procedure pertaining to so many type of variables. The method of drilling, we have different methods of drilling, and in that, for the correct value of n value, rotary drilling is the best one that was suggested. And cleaning of the bottom hole, especially in the case of sands, we have a collapse of the borehole is there. Suppose if the borehole is not cleaned properly, and there is a fall of loose material that is in the caving of the borehole material and the top surface and the test surface, that represents the incorrect value of the n value. That is, it's a partly or fully representation of the caving material, or it leads to some sort of representation of the two soil mass that was there in the borehole. Therefore, it requires a flushing of the borehole before conducting the testing. Next one is the lacking of the drill muds. Yes, just now discussed, in the case of sand, there is a probability of caving, that is the collapse of the borehole. If there is a collapse of the borehole, we should use a drilling fluid or drilling mud such that the borehole should not be collapsed, and the test that was conducted should be only in the virgin soil, that is the parent soil without any caving soil that was from the borehole collapse. And regarding the diameter of the drill hole is considered, we have different diameters are there. As per the soil investigation point of view, we are using different diameters also, ranging from 65 mm to 150 mm. 150 mm generally is possible in the case of a wash for the tripod type of drilling mechanism using wash boring, or something like any rotary drilling equipment. 150 mm generally is the case we are using, and minimum should be 65 mm. If it is minimum 65 mm, less than 65 mm, the borehole is not give a proper result, not only for the this testing point of view, also for the splitting testing point of view. Minimum diameter should be maintained as a 65 mm. And the location of the hammer, that is depends upon the drill length that was inserted into the borehole. We have the anvil placement is there, that is the anvil and the dropping mechanism is just at the collar surface or at some depth above the ground surface. This height also plays an important role. Why? Because your lifting mechanism is entirely dependent upon the place above the collar or top of the borehole, which is too high above the ground level. We are unable to control the lift, and the lift height will vary because of the non-convenient position of the anvil mechanism that is above the ground surface. When it is close to the collar or the ground surface, you can have a control on the height of lift, especially when using manual methods of lifting. And the hammers, we have different type of hammers: automatic hammers, manual hammers, and we have the total control about the system. That is, in terms of automatic hammers are the more preferable one. Number of tons, that is on the cat head, we have we can be either the 2.5 tons is preferable. The frictional distance between the rope and the cat head is also plays an important role. Generally, 2.5 tons is preferred, but to minimize the friction between the shims of the cat head and the rope. And once we are using any rotary mechanism, this friction is not a problem. Being a rate of operation is constant, almost controlled by the mechanical power of the equipment. And actually, the hammer drop rate is the main factor which varies the n value. This error is reported generally as 25%. Next one is mass of the anvil. That is the energy is transmitting to the anvil, from the anvil to the drill rods. If too much of heavy mass of the anvil is there, it will be energy absorption at the anvil itself, and the energy loss is more. Therefore, the mass of the anvil should be not too much, and it should have transmit the maximum kinetic energy to the drill rods and finally to the your split spoon. And friction in the guide ropes. We have guide ropes that is moving around the sheaves of the tripod, and also these are moving around the your winch. All this will have to create some sort of friction. And generally, if to minimize that, we have to apply some oil to the guide rope and the sheaves. And the tightness of the drill rods is also important parameters, which highly affects the your input energy and the line of the sample. This point already we have discussed, and this liner entering of the fines into the outside of the liner gives some sort of errors in the n value that was reported, and rate at which the blows are important. For Indian conditions using manual methods, generally this is one of the important factors we have to consider. The fall rate will be generally up to for 2 seconds there will be one blow. that is the rate of fall of that falling weight. Unless and until this uniform rate is maintained, there will be a probability of occurrence of the reported N value. Out of this, the main influencing factors is actually the drop weight that leads to a 25% error. Suppose if I reported 10 N value is the field value is at 10, it comes to be 7 only. Otherwise, in most of the cases, it's not more than the highest 7 came left. The rate will be less. Therefore, your this actual you are reporting a wrong value with respect to other than the drop rate of the hammer. What if I mentioned? This is the international practice we have. Like Indian practice, before going to this, I will show you one of the slides regarding the Indian conditions. Thereby, we can answer one hour. Before going to that, we have different hammers are there. These hammers are nothing but a donut hammer. We have the safety hammer and the automatic hammer. The basic difference is the height of control over the height of fall of the hammer. In the case of donut hammer, there is no much of control is there. And in the case of safety hammer, there is a perfect control, and also the safety of the drilling workers is also involved by locking at the top. And you have automatic lifting and falling is there in the case of a automatic hammer. In Indian conditions, we are mostly using this donut hammer, whereas the UK practice is adopting a safety hammer and automatic hammer. In US also, we are using both the cases. Yeah, these are the schematics showing the donut hammer and the automatic hammer as per the ASTM standard. Yeah, this is the Indian practice of as per IS 2131 using donut hammer, and this is the soil sample collected in the split barrel after the completion of the test. Yeah, this is the hand drop method. It is also international practice. Indian local practices generally, for the sake of simplicity, we are using hand drop method. In this, the basic advantage is we have the control over the drop rate and also the fall rate, but there is no control over the safety of the testing is considered. In China also is we are considered, and Brazil also we have similar equipment is there. For this Indian conditions, this drop rate is correspond to the energy ratio of 55%. And whereas in some countries like Brazil, they report 72%. In China, they report as 55% energy ratio. This is the PDA equipment from US. Just now we have discussed the energy ratio that is transmitted to the drill rod is much more important. Once we are unable to measure the energy that is transmitted to the drill rods, there is definitely other than the reported N values. To standardize that, the PDA from USA has developed sophisticated equipment. This equipment is nothing but the one equipment we are using for the conducting of dynamic pilot test. In this, we have the sensor there. These sensors we are fitted to the split barrel. The sensor will be looking like that, and this is the data acquisition system. The data acquisition system collects the data and it filters the data by removing the unwanted signals or the unwanted noise, and after that it conditions, and after conditioning it will process by amplifying it. Now in India, like a sophisticated geotechnical companies like TBM and also they were using this equipment. The basic concept is we are fixing some acceleration gauges and the strain gauges to the split barrel, and using which we can get a acceleration spectrum similar to a displacement spectrum and the acceleration spectrum similar to an earthquake seismograph, by electrical spectrum analysis or spectrogram. That spectrogram is analyzed for the energy that was actually transmitted to the drill rods. This, once we measure the actual energy that is transmitted to the drill rods, this energy can be directly used in our calculations. We'll see now what is the calculation that is to be incorporated. Yeah. Generally, there are two corrections that were suggested in the code. That is IS 2131. There is two corrections are there. One is the form of wall burden correction. Second one is the form of a delta density correction. A wall burden correction is required for all types of soils, whereas the delta density correction is required only in the case of fine sands or the silty sands below the water table, where there is a chance of development of negative pore pressure is there. Under the development of negative pore pressure, you have the there is rebounds is there with respect to the penetration of the split spoon. Therefore, we have to apply the reported N value is somewhat higher than the actual value. Therefore, we have to correct it. The correction is always negative since we are reporting a higher value. That correction is nothing but 15 plus half of 15 and minus 15. That is a simple correction we have. And the sequence of application of the correction is first we have to apply the wall burden correction. Then we have to apply the delta density correction. Delta density correction, now way modern day thinking is that there is no requirement of the delta density correction is required. But in our some of the experience while conducting file load tests, we found that delta density effect is there even when the files also at small load increments of the file. We observe this phenomenon practically at AM regions while conducting load tests on fine sands or fine silty sands. We clearly using load plots or settlement plots, we observe this negative pore pressure conditions are occurring in our area also. And regarding these corrections are required, as suggested by the JE Bowles, that is Joseph E. Bowles, and as per the IS 1893-2016. In 2016 version, the code suggested that some sort of cyclic stress ratio for the determination of the liquefaction potential of the fine sands and the seals. They mentioned clearly in the appendix, that is the annex that they have, clearly mentioned the procedure for obtaining the N value for using is as a design parameter in finding the cyclic stress ratio. This cyclic stress ratio is nothing but it's a factor which determines the liquefaction susceptibility of the fine sands or the seals. That is generally reported in a soil investigation report. Once we are aiming for the design with respect to seismic point of view, that is the foundation is also to be designed with respect to a seismic bearing capacity. Not only that, it should be designed for the seismic liquefaction resistance. And these are the corrections suggested in the international literature, and also latest version of 1892 also suggested this corrections. And in this, N60 is a standard value, that is a universal value. N value is the standard field value. And for this, by 60 corresponds to your energy ratio corresponds to 60 ratio. As per the Indian conditions are considered, based upon our previous experience, some researchers have reported that our standard equipment and daily practices, based upon that, they reported 50%. Some reported 55%. The lowest value we are taking 50% is the energy ratio that is corresponding to a Indian conditions are considered. And according to the research work of Seed 1995 and Stunter 1996, they've suggested this equation N60 is N times of efficiency due to the hammer, efficiency due to the sample, and efficiency due to the your borehole diameter. These three corrections, including the 60 value that is corresponding to energy ratio 60% was suggested by Seed 1985 work and also the Skelton's work 1986. The hammer conditions just now I explained. And the standard sample without liner, generally that is the case we are using. That is one. There is no corrections required. For the borehole diameter, suppose we are using a drop pipe with hammer that is generally 50 mm to 55 mm. But for that, regarding 60 mm borehole diameter, we have to apply. And regarding the test depth is considered, just now I explained, the buckling of the drill rods plays an important role. If more the drill rod done, there will be more the buckling in the column. This is similar to a long column method. A long column will have much more the deflections, lateral deflection. That is a second order deflections. In a similar fashion, under the potential energy, there is some sort of lateral buckling in the form of pinned columns. That buckling effects is to be encountered by in a practical situation using this correction factor of rod length. Yeah. This is the simple criterion we have for the design of the foundation system. The safe bearing capacity is just now we have explained is pertaining to a shear failure, and the safe bearing pressure is corresponding to a a settlement failure. The settlement will be generally in the form of two settlements. One is in the form of total settlements, and second one is the form of differential settlements. These two are important. The total settlements will not have any detrimental effects to the structural system. That is the system reactions. We have generally considered the shear forces, bending moments, and axial forces in the columns. Then the shear force and bending moments will be affected with any settlement in the support system. The settlement will be reflected with the settlement of the the columns and settlements in the beams. For any delta of settlement, we have additional investment of 68 delta by L square for the additional movement, and 28 delta by L cube. That is the additional shear force that is generated with the delta settlement of the corresponding support. Then the total settlements will not give you any hamper your safety. Why? Because it is a problem with respect to only the breakage of the connection with respect to the your appetances or nullas or lines what you are providing. That connections will be broken up, and also your the car movement, parking, and all that will have some sort of difficulty. Otherwise, there is not problem with the total settlements, and there is a much problem with the differential settlements. These differential settlements, just now I explained, we have a highly detrimental value. Settlement will always induce additional shear forces and additional bending movements that we generally not encounter during the design step. That is not we are considering at the design step. These are the additional process generated for which the structure is subjected to and will be accepted. We have the limitations with respect to the total settlements, also for the differential settlements as specified in the table 1 of IS 1904. Differential settlements, it is difficult to measure. Therefore, we are representing in the form of tilt or a percentage of total settlement. That is, the percentage will be generally 2/3 or some 70% will be the total settlements. And also, it is a function of the type of the soil and type of the structure, whether it is a steel structure or masonry structure. Also, it is a function of the type of foundation also. Like rafts, you have the much more permissible values being having high rigidity, and the probability of occurrence of differential settlements are minimum. Why? Because the differential settlements will be pitched up under the combined action or the rigidity action of the. And these values are there in the international literature also, like McDonald 1964. And in the case of dynamic forces, you are considering like design of any machine foundation. You are thinking in terms of the permissible amplitudes of the machinery foundation. Like Richard's chart. This is the standard chart we have, based upon which we can permit the dynamic amplitudes. Can we imagine what is the magnitude of the dynamic amplitudes? Generally, for the foundation design of any machine foundation is it's not more than 1 mm. That much of accuracy is required. And the understanding of SPC and SPP, already we discussed this point. Time. Yeah. This computation of the settlements, this is much more important. I'm skipping this for the time sake point of view. Yeah. This is a case study. We discussed that there is some sort of layered soils are there in the Kakinada region, especially the areas of Lakshmi Nagar, road number 4, and the surrounding areas of Godari Gunta of Kakinada area. We have a typical profiles, like we have soft clay zones are there from the ground surface itself, having some depth of 1 meter or 2 meters, some sand zone is there, followed by soft clay. In some locations, we encountered after 1.5 meters or 2 meters, there is a soft clay existence there. These will give a special type of problems, like what is the bearing capacity and what is the settlement. That is of the importance regarding the allowable bearing pressure is concerned. The allowable bearing pressure in this case will be affected in both the cases. That is SBP point of view also, SBC point of view. Generally, in a theoretical case, only whether SBC will cover or SBP will cover. For Kakinada, we have a special advantage. We can say a special problem that was posed to our engineers. That is nothing but we have problem with respect to the both SBP and SBC. Why? Because we are considering being soft place. The soft place bearing capacity not more than 2 or 3 tons per meter, so that the maximum 4 tons per meter. Being extense of a overlay in the sand zone depth of 2 meters or 3 meters, after directing this depth of foundation of 1.5, 2 meters, we have at least a 1.5, 2 meters below the sand layer, and followed by marine soft clay, that is in the form of a soft to very soft clay. That governs our bearing capacity also. For that, we have to use a Madoff's bearing capacity equation for the two-layer soil system using punching shear. The punching shear coefficient is to be adapted. That comes to we need about 1.8 to 2 for the Kakinada things. And that values to be derived from the charts given by the Madoff. And we have to design for the SBC. That SBC nearly comes to be 6 tons per meter square. That is a bearing pressure that is safe against the shear stress point of view. Again, under the 6 tons per meter square of loading, that is the bearing pressure we are applying in the foundation soils. We have to check what is the settlements that is coming to be, that is expected to be after the completion of the structure within the performance, that is during the design of the structure. That is a course of importance. In most of the cases, what we found that this SBP value, that is the settlement Gauss criterion, once we look into the code, the permissible values for the case of RCC building with isolated footing resting on place, that is maximum value of 75 mm, which is a raft, it is 100 mm. Taking this 75 mm as the limit, even 75 mm also is a higher value, but taking directly from the code, 75 mm is the higher value. We are computing the actual settlements under the intensity of 60 kPa. That is a global bearing pressure we are applying on the foundation soils. We compute based upon the two-layer soil system and using the standard Target's one-dimensional consolidated theory for the soft layers and also for the immediate settlement for the sand. To the surface, these settlements will be around, without applying any depth factor, will be around 150 to 170 mm. In some of the cases, it can be 190 also. By applying the suitable rigidity factors and like depth factor and all that, the settlements can be coming to a net value of 125 mm. That is crossing the permissible limit that was given in the code, that is 1904. Whether we have to go with that such type of bearing pressures or not is the decision of the engineers. Once we speaking code as a mandatory, we should not go in a foundation. Pipe foundation is the only alternative. Suppose we are, there's a private work, we are compromising and some sort of techniques like design techniques, we are capable of adapting it or designing it, then we can have a reduction of the settlements that just now we'll discuss, and that can be allowed with slightly crossing its permissible value of 75 mm. Yeah, this is a FEM model that was created using the STAT, but is supposed to be created and generated in the geotechnical softwares like GeoSuite or Plaxis or OS software. As being a STAT is easily available in most of our design offices for the easy understanding of the engineers, like fellow engineers. I modeled this footing using STAT as a 3-layer soil system for the case of the Lakshminagar area. That is belongs to one of the doctors in the Kakinada city. The typical soil profile is just now I have shown you. The footing depth is 2 meters, and you have the topsoil is a medium stiff clay of 1.9 meters depth, and you have a medium dense sand of depth of 1.8 meters, and you have the very soft clay that is the N value looks to be 0. The beauty of the soil is the N values are 0. But and this is having a CU value of and is about 6 kPa the CU value is, and you have the much influence of the soft layer with a depth of foundation 2 meters. The depth of influence is 0.9 meters in the stiff clay region and 1.8 meters in the dense fan sand. And they are about 3.3, I think. 3.3 meters is the depth of influence of the soft clay. This soft clay is playing a vital important role not only in the strength point of view and also the settlement point of view. We computed the settlements using the both methods, using manual methods and also using the STAT model. Why we have not used the Praxis is somewhat difficult. It requires some sort of training and understanding of the software. For the easy understanding, I have modeled in the STAT using that Borlaug soil stratification. That is, we have 0.9 meters after detecting 2 meters depth of foundation. We have depth of influence of 0.9 meters. Medium stiff soil is there, and again fine sand influence is 1.8 meters. And this is a medium dense to dense. Sorry, medium dense soil is there. And after that, soft layer, very soft layer is there. That is 3.3 meters there. This is the total depth of influence of the soft layer. And this is the shear planes development. And correspondingly, also we can have the development of the shear strength. That is the total pressure bulk that was taking place in the soil mass. And the computed settlements will be around using manual calculations of one-dimensional consolidation theory and also the immediate settlements of the sand, and also the settlements of the medium stiff layer. In total comes to be 176.2 mm. This is nothing but it's for the flexible footing that was modeled and without applying as a surface footing. This is a surface footing model that is we have applied as a surface loads, and also this is a contact stress distribution being a flexible footing like this. And without applying the rigidity factor, this is with application of this rigidity factor, it comes to be about 140 mm. This is a standard model. This comes to be 109.7 mm. That is investment below the soil mass, that is below the footing. This comes to be 149.7 mm. The difference of 25 to 26 mm is there. But once we apply the rigidity factor, but instead in morning, for this morning, it will not consider the depth factor. That's why we compare this settlement value with respect to non-application of the depth factor. Once here we apply this depth factor, it comes to near about 140, 143 mm. Next. Yeah, this is the concept of understanding of bulb of important to understand the design of foundations, especially to design the foundations for the minimum settlements. Whether we can design a foundation for the minimum settlement, that is a total settlement and differential settlement. These differential settlements are always a function of the total settlements. The total settlements we can control. As a designer, we can control. That we, for controlling, we should have the understanding of the bulb pressure. Yes, we know the bulb pressure is something like a bulb, like the incandescent lamp or an onion. It will be in the form of a circular footing spheroid, or for rectangle, a oblong parallelepiped, and a square footing, it's oblong cuboid. And it's should be thinking of in terms of the 3D model or 3D shape. Why? Because in the textbook point of view, we think and learn up to this point only. But we generally learn with respect to the three-dimensional effect of the stress bulb. In the case of a footings like rectangular footings or strip footings, the actual pressure bulb will have two effects. That is, we have one dimension of B, that is the width of the footing, and the second dimension we have a length of the footing. The B plays the important role, that is the stress distribution, the soil mass, that is to what's the depth. Length has a signal point on the lateral spread of the your stress distribution. This point is to be clearly understood. Generally, in textbooks and any literature, this point is not highlighted. This point of understanding is very important for the properly designing of any foundation for load settlements. Once we understand this concept, we can play the game with the foundation systems. Therefore, at the crux, I will explain once again. This B plays an important role in the distribution of the stress to the soil mass in the depth region. That is, the jet value will be stress distribution. Jet value will be affected by the B, and the length value that was there will be affected by the your this length value will be governed by the lateral spreading of the pressure bulb, that is the lateral stress distribution will be like this. And these circles are nothing but the concentric circles that is generated from the edge of the footing and will be propagating. And up to 2B, there will be a stress transmission of 70%. Beyond that 2B, we have 30% stress distribution there. Most of the stress distribution will be within that 2B zone, that is 70% will be distributed. But 90% will be distributed more than 4B. That is not significant. At least 2B we have to consider, in which 70% of the applied stress at the footing level will be distributed in this soil mass of 2B. Yes, we just now discussed this. Without the footing plays an always important role towards the stress transmission depth. Once we restrict the without the foundation, we can able to restrict the bulb pressure. Once we restrict the bulb pressure, the number of influencing zones that is in the soils, especially as just now we discussed, these soft clays plays important role, major role in giving the maximum settlements. Once we restrict the bulb pressure to the soft clay zone, we can able to restrict the settlements. For that, what we have to do is we have to proportionate the footing such that the B value should be minimum. How that can be practically possible? That was tried in one of the projects. This is the case pertaining to a design of an apartment and including the foundation also. Here we have a typical soil profile of about 3.5 meters, 5.5 meters sand dune is there. In that sand dune, again, we have top layer is uh, Yeah, the top soil is fine sand to fine silty sand up to 5.5 meters depth, and below that there is soft place there having a CU value of other 10 kp. That corresponds to N value of 1 to 2, maximum it is 2, and at least comes to be 1. For that case, the bulb of pressure is considering 2 meters in the depth of the foundation, 3.5 meters into the fine sand, and the remaining bulb of pressure is in the soft clay. This gives a problem for adapting a shallow foundation. What we have designed is the G plus 5 storage building, a case study, and the maximum column load coming is 130 metric tons. And the foundation soils are typically a two-layer soil system with sand underlain by the soft clays, and the locations at Bimbaram. Under the maximum load, the footing size is coming to be near about 4 meters. 4 to 4.5 meters, that is the footing size is coming. The bearing capacity, that is say bearing pressure, is coming to be nearly up to 6 tons per meter square. Under that 6 tons per meter square, near about 4.5 meters of width of the foundation, the settlements are going beyond the permissible limits, near about 170 to 180 mm is coming. For that, what we did is, we instead of adapting a individual isolated footings, we adapted a slip footing such that the width of the foundation for footing is not much. That is, we have connected like a slip taps like to 1.5 meters, 2 meters, maximum 3.4 meters. With restricting the depth of the foundation, our pressure will not be going much beyond the farther depth into the software. That is our concept of design. Once we restrict the operation of the software, the settlements that what we have encountered, well, we have control over that. Even though they were exceeding, but the exceed is not beyond too much. That's the concept we have used. This is actual slip footing. For the slip footing, we have designed the foundation system accordingly by restricting the bulb of pressure. That was the concept adapted here. Therefore, we have to think what is the minimization of the width of the foundation. Thereby, the total settlements was minimized. And one more technique we have adapted is use of some sand layer of 300 mm to 500 mm. Why? Because this sand layer that is below the PCC will act as a drainage path to the consolidation of the soil stratum. Generally, for the particular case, we have a sand dune is there that will accelerate the consolidation as a one-dimensional 1D drainage system. In the case of where the sand dunes are there in contact with the soils, we have to provide a sand dune depth of not less than 300 mm, such that this will act as a some sort of drainage to the whole pressure distribution or dissipation, and that to minimize the consolidation settlements which are going much beyond the your total settlements of as prescribed by the code. That is, there is a correction factor lambda is there in the IS 8009. You can refer that values, and once you have the better drainage system is there, the practical consolidation settlements that is occurring is much lower than what we have anticipated during the analysis stage or any computation stage. Yeah. Remoteness of failure. Regarding the failure is considered, we are generally bothering about the failure. We have two types of failure, whether the foundation can failure or it can be the structure can be failure. For the design of foundation system, we are adopting a higher factor of safety as being they were highly erratic and heterogeneous in nature, and also the number of soil investigation boreholes we are conducting is not sufficient as per the product requirement or the importance requirement is concerned. Also, the MGU value, that is, but the variation in the lateral direction is considered when we are designing a large project, that is also plays an important role. And regarding the safeties are considered, it's most likely the superstructure will fail when compared to a substructure. Why? Because the factor of safety is involved in the case of a substructure are higher, and also we are adopting a multiple factor safety format for the design of substructures and also for the design of the superstructures. In the case of substructures, adopting higher factor of safeties, the equilibrium equations, that is the ultimate load states will not be reached. Suppose if a structure is designed for the 100 ton, a footing is designed for 100 tons of load. In the structural point of view, once it is crossing 20% beyond that, it leads to elastoplastic behavior to the maximum as a load factor we consider as a 1.5. once we consider the crossing 150 tons, the structure is under almost a failure condition by reaching its ultimate value. But under the soil point of view is considered 100 tons into 2.5. 100 tons is a corresponding bearing pressure. Suppose we assume as 10 tons per meter square. 10 into 2.5, that is near about 255 and 25 tons per square meters is the allowable value up to which we can't expect any failure. Therefore, it is the most likely that the substructures will generally not able to fail, and the structures are more liable to fail. Even though that we should be extremely careful. Why? Because there are so many variables, there are so many parameters. Even the single mistake in the n value leads to the behavior of the changes in the response of the structural system. This is one of the typical failure. That is the punching shear failure is there. I have extracted from one of the famous textbooks in international literature that shows how the structure is failing in a punching shear. What a catastrophe. Finally, I read this my most likely interesting quotation. Unfortunately, soils are made by nature and not by man. The products of the nature are always complex. This is the quotation given by father of soil mechanics, Carl von Ritschke. Thanks for your patient listening.
Thank you, sir.
Thank you, Dr. Narasimha garu, for your valuable lecture on sensitivity of foundations. Your lecture gives us understanding of different soil failures under foundations, standard method of SPT test, various settlement cases, finite element method for a 3-layer soil system, concept of pressure bulb, and various live cases. Thank you, Narasimha garu. Now I request the participants to raise the questions.
Hello.
Hello, sir.
Hello.
Hello, sir.
Durga Prasad garu.
Yes, sir.
Hello.
You're listening. Sir, you're audible, sir.
Dr. Subbarao garu. Namaste అండి.
Namaste, sir. Namaste, Sundara garu.
Sir.
Namaste, sir. Namaste. Thank you. Thanks for listening, sir.
Yeah, Dr. Narasimha garu. Very congratulations.
Thank you, sir. Thank you.
At the outset, I must thank you one and all for this very great opportunity. I appreciate the activities of this chapter. It's very useful and very relevant to the need of the hour. And at the outset, just I would like to congratulate the office bearers of the next, tenure for the 2 years. Sundara garu, congratulations, sir, for your
Thank you, sir. Thank you, sir.
coming forward and taking this responsibility and taking it for the benefit of many fraternity of the civil engineering practicing engineer as well as the academicians also.
Sir, thank you, sir. And we need your support, sir.
Yeah, I mean, just I noted that your vision.
Yes, sir.
So you decide to have these sessions offline, it will be more effective. Of course, if the situation will be conducive, and definitely it can be.
Yes.
And also
Yes.
enrollment of all the many people.
What-
Yes.
One more thing, sir. What I request you, sir, you please share the link in your group, sir, in your students group, so that.
I do it.
Yes, sir. Yes, sir.
I receive this, of course, I also there in the group, and the moment I receive this link, and generally I have a habit of passing on to all the people, whether they join it or not. That's a different, and of course I remind them also in person by calling them who are really interested in that.
Thank you, sir. Thank you, sir.
So definitely we can make use of these locally available engineering colleges, and of course this is something like the theory and practice should go hand in hand, right? And one more thing just I would like to suggest is that we have been conducting many lectures. Is it possible to get these proceedings in the form of proceedings at the end of an year, so that this can be available for the people? See, just listening and the people may forget it. So
Yes,
therefore, in the need of the hour, if this proceedings is available, and
Yes.
then it can be like a referring manual, like those people. So that's my suggestion. That would be good actually.
Yes, sir. Sir, one thing we are doing, sir, we are having a YouTube channel, sir. In that YouTube channel, we are uploading all these webinars, sir.
Okay, audio webinar, I mean, lectures are made available. Okay.
Yes, sir.
Yes, sir. All lectures are available in YouTube channel as well as in Facebook, sir. Those links I will forward, sir. I will forward in group, sir.
Okay.
As
So,
you said,
of
I
course,
will.
they may be available in the YouTube, but
Yes,
if they type it and then they get it.
yes, sir. Definitely, I will share the links, all the links in a format, sir. Definitely, I will share all the links, sir, in a proceeding format.
Right.
Yes, sir.
Right. And of course, so Narasimha garu,
చెప్పండి సార్.
very congratulations. It's very
Thank
interesting
you, thank you, sir. Thank you.
and enlightening. Almost like reviewing the whole soil mechanics subject from B.Tech course to the M.Tech course. Yeah, you have taken a journey from 2000 BC to 2020 AD. It's a journey of almost like 4,000 years. You have mentioned everything.
Yes, sir.
And of course, so generally the people who feels that it's a very known topic and of course there is nothing to be learned. For those people, I have a message to them. There will be always gaps. There will be always some voids. By listening once more also, it will be multiple purpose. Those gaps will be get filled. And then it's something like a refreshing and reviewing. And also it's something like viewing the same point from others' point of view. So that will be very effective. And yeah, the very topic is very need of the hour, sensitivity of the foundations. Even the title substructure and superstructure, maybe people are carried by this title. Superstructure means it's a superior structure, it has to be taken care of more. And the substructure need to be under treated like it's not that. So this foundation engineering and this subject need to be emphasized. That is the more important. My teacher used to quote this: గోడకి నిచ్చిన ఆధారమా నిచ్చెనకి గోడ ఆధారమా, something like that. So thereby, for the combination of this wall and the ladder should be successful and stable, first of all, the wall should be strong enough and then the ladder has to be. And one more suggestion that I wanted to, regarding this, of course, Narasimha has mentioned the soil site conditions of in and around the Kakinada. Is it possible to have a soil map of Kakinada indicating this, what you call that, the bearing capacities and types of soils, SPC contour maps? And for that, we can make use of the, I think the civil engineering department soil investigations reports also, because most of these structures are constructed in all the locations of this Kakinada, and all the people might have got tested their soils. Their reports may be available there, and it could be a great service to this consulting engineer and all other engineers if it could be done. That's what I feel like. Soil map, contour maps of SBC.
Yes,
Yeah,
sir.
so types of failures and types of foundations. Yeah, the many things have been. I consider him Narasimha garu.
Sir, regarding your suggestion is considered, sir. Generally, soil point of view is considered is natural dependent site specific criterion, sir. Like
Okay.
it varies with the site and also the what not only the site stratification, it also depends upon the density existence. Like in sands, we have different densities is there. Like in Jagannathpur area, we have loose sands are there. In some of the areas, we have medium dense sands are there. Like the some of the areas, we have the dense sands also there. And the one aspect we can club it, sir. Like already in IITs, like IIT Delhi is doing the microgeneration of the Delhi city, and that will be helpful to plan the hazardous map. Like in the event of post earthquake occurrence, the communication towers and also what are the utility services required on emergency basis. That should be planned based upon the microgeneration map of the seismic activity of the particular region. Sir. That activity was done by IIT Delhi for the Delhi city point of view is concerned. Your solution is good, sir, regarding this. The practical problem that comes with is we can have that soil maps, sir. Like we have so many boards along with us, and also from JNT,
Right.
they had the very good number of, and also Sundaragar have a very excellent work of the soil investigations. Coming on this, we can have the some sort of soil map of pertaining to Kakinada. And our geology madam from JNT Kakinada also have made a similar effort, sir. Like one of the, as per my knowledge is considered, Mr. Varprasad has did some work under the madam guidance, sir. And that work is pertaining to the classification of the soils based upon the GIS applications. Yeah, what they did is they've identified the some sort of both charts, and that both charts was again calibrated using the GIS maps, and the GIS maps was again prepared for the other cases, like something like a correlation analysis. It's a good work, sir. It gives the insight of the any structural engineer or geotechnical engineer before going to the in depth of geotechnical investigations. It is something like a recognition survey where we, in the survey point of view or soil mechanics point of view, we generally go to the site and we'll have observation over the site. What is the probabilities of the type of soils that we'll encounter, and what are the equipment that is to be planned, and what are the broad outline of the geotechnical investigation is to be adapted. For all this point of view, your suggestion is good, sir. Like in that manner, we can incorporate. The main problem that comes is with the soil is site specific criterion, soil parameters, and within the Kakinada also we have a very wide variety of stratification, and also the density is related to density of the sand, and also the what we call these strength parameters, which are the governing criterion for the design of any foundations are considered. These are highly erratic. So what I have observed is from my experience, this high variety is there. But in that cases, in the case of a structure which is of low rise structure, if this database is there, just to have the proper investigation, that will be helpful in the databases point of view. He will collect the data from the previous nearby data, and he can utilize that services. In that manner, it is highly helpful for the recognition point of view, and also for the planning of the equipment and the planning of the even methodology and all that. It will be also definitely helpful to the client, not only to the client, to the designer also. Sir. Already, madam had tried that, sir, and hope further research work is to be conducted.
Right. But we have to join together, like lab and land should be connected together.
Yes, sir. Yes, sir. To the fortunate, I have some interaction with Mr. Varprasad and madam also in giving some of the suggestions regarding the Varprasad work, sir. Yeah, it's a good work, sir, actually.
Mr. Badam Sundar, I am Sri Secretary, Bangalore Center.
Sir, good morning, sir.
Very nice to hear from you. Congratulations. And you are doing a very fantastic job for Kakinada Center in enhancing the knowledge of your surrounding, your members, and beneficial to most of the consulting civil engineers and other contract and other practicing civil engineers. So very good programs, and I am observing your lectures, and some of them I attend, and very informative, and really a good move. In fact, after opening the center, I feel that you have given a lot of lectures from your center. It is a very good progress, and you have taken responsibility, and you have kept it up. Congratulations. And I have one small, kind of a suggestion. You might have been there yesterday's Surya Prakash lecture also. You might have heard in the professionalism of civil engineering, which we are conducting from Bangalore Center.
Yeah.
See, with that regard, the next this thing will be the legal disputes, and after that it will be on civil engineering curriculum, which has been diluted. Which I want to talk about that. 2 minutes only I will take. Yeah. We were going through the syllabus of various engineering colleges nowadays, because down the line, when we were studying, We had
Yeah.
studied about history of architecture, town planning, then building drawings, and then isometric views and so many things. But
Yes,
the
sir.
whole thing has been totally removed from today's syllabus of engineering colleges and institutions. This
Yes,
is
sir.
very unfortunate.
Yeah.
And that particular, the divide of the students are being divided of these subjects, making our profession as totally dependent on somebody else, which we should not allow to happen.
Yes,
And as you are being almost the leader in that particular consultation and other aspects of engineering fraternity, you
sir.
please think about in these lines. And if you
Sir.
are somewhere in the colleges or anything, you please
Yeah.
try to change them and incorporate these subjects. We are
Yes,
also
sir.
trying at our level here in Karnataka to
Yeah.
enhance the civil engineering syllabus, which was there earlier, and now
Yeah.
it has been diluted to a very larger extent. It is really a worrying part.
Yeah.
The students which come out of the colleges, when we take the interview and all that, they
Yeah.
don't know anything about the building element parts at all. They
Yes, sir.
don't know what is flooring aspect, how it has to be done.
Yeah.
There is no finishing parameters. What is the
Yeah.
building height means they don't know anything. What is the lintel height they don't know. So like
Yes,
that, there are many problems which we need to cultivate the habits to understand in our
Yeah.
future students. Which
Yes,
just
sir.
I wanted to have a word with you.
Yeah.
Thank you for your lecture, and I heard it. Very nice to hear from you. Thank you, Mr. Udam Sundar.
Thank you, sir. Actually, I am a member in Board of Studies of JNTU Kakinada, sir. We being a part in that Board of Studies, we made lot of changes in the syllabus, sir. And subjects also were changed based on state of art requirement. If possible, I will share that syllabus to you so that it will be useful for our further actions.
Oh, sure. Thank you.
Okay, sir.
Thank you.
Okay. Thank you.
Thank
Thank
you,
you.
thank you, Srikanth sir.
Can I ask a question now
Yes, sir.
to the speaker?
Yeah, tell me, sir.
See, you are using this standard penetration test to evaluate allowable bearing capacity in a particular area.
Fine.
How do you see the n value that you get would be as per the on the particular time of the year when the test is conducted.
Yeah.
How do you account for seasonal variations in water table?
Mhm. Fine, sir. Yeah, the N value is generally pertaining to a cohesionless soils, like in the fine sands or silts are there. A mixture of silts and sand. The test is meant for that. And in the case of a sands, we have to think of the what is the variability of the N value with respect to the angle of shearing resistance. That is the final outcome. The final result of N value is to establish the phi value. Once we see the groundwater table effect on the phi value, the research says that the phi value is not significant on the variation in the groundwater table. The effect of groundwater table as saturation and submergence we call it as that is only 1 degree to 2 degree, not more than 2 degrees. Generally, most of the cases is not more than the effect of water table at the submergence, not more than 1 degree that is there. The what is the distance that is obtained from the N value will not that much have significant variation in the reported value is considered with respect to water table. In the case of posy soils, that is not actually truly applicable case, but we can have the variation in the CU value. The soil characteristics, especially the cohesion value, is highly dependent upon your saturation level. That affects your N value. And practical point of view also, we should not consider that value for the design point of view is considered.
I have another question.
Yeah, tell me, sir.
See, when you do this geotechnical investigation on any site, you take a limited number of boreholes.
Yeah.
So whatever soil profile you arrive at or you get from the borehole, how much how are you sure that it is the profile on the entire the layer thickness of various soil layers is uniform on the entire site or the footprint of the building? And
Yeah.
in the example that you gave, you calculated a settlement of almost 175 mm or so.
Mm.
So with that high this soil settlement of the foundations, how can you be sure that differential settlement or tilting of the foundation will not happen?
Mm. Fine, sir. Regarding the number of boreholes are considered, we have the IS code is there for the subsurface investigation, both for the rock mechanics point of view, also soil mechanics point of view. Once we think of in terms of the lateral extent of the variation, generally we think 50 meters is the minimum geological unit. That is, minimum geological unit is one which the lateral variation of the soil stratification is considered. For that, what is the practical case we generally adopted is based upon the survey that was conducted at the field to the boundaries. They will categorize into, distinguish into a different grids. And based upon the grid pattern, just we, first of all, we propose the preliminary investigation boreholes. We observe the variation in the preliminary boreholes. After that observation of the preliminary boreholes, we can have some estimated profile of the variation by plotting the two-dimensional profiles. That is with respect to the your site grid map, with respect to the your corresponding levels and all that. You can observe the what is the variation that is taking place. If the variation is much more, the second stage of investigation is with respect to the secondary boreholes. And after that, if the variation is that too much is there, then we go with a site structure specific investigations. Like in the case of a bridge engineering, we generally suggest each borehole for the one abutment at one pier. That is more the site specific criterion. For larger sites like any power plant structures or like any industrial developments, we generally go with for each acre, generally one borehole is the criterion. Otherwise, if any survey report is there, like any like total station survey is there, they will divide the site into different grids. Based upon the grid pattern, we conduct the preliminary boreholes. After the preliminary boreholes, we plot a two-dimensional profile with respect to levels also, and we'll observe the variation. Based upon the variation, we go with the secondary boreholes. And if any much more important is there, that we go with the site-specific and structure-specific. That is the general criteria.
And under what situation do you recommend triaxial testing?
Triaxial test is the most practical and the correct way of testing, being the stress stage in the soil is to be assessed first. Whether suppose the saturation is there and clay, like soft place and very soft place into medium stiff places there, and saturated conditions, the UCC test, this is the unconfined test, this is a simple test we have, that simulates the only the axial stress application, that is sigma 1 major principal stress, that is more than sufficient. For the case of sands, we have this requirement of axial test is not only sands, in the clays where the saturation is not 100%, and also the your axial state of practical application we have to consider. That depends upon your the type of loading that is coming at the type of structure also. And based upon that, we have to observe the soil mass, whether it is a axial state of stress or a single uniaxial state of stress. Based upon that, we have to choose your the type of testing. And one more criterion is that is if you have parameters, like you require the total stress parameters or any drainage parameters are required, that also distinguishes the type of testing. In the case of embankment, after post construction, you require some sort of CD testing also. Generally, we design for the embankments. That embankment requires the C5 and 5. That depends upon the time of loading and the nature of loading.
Thank you very much.
Mr. Madam, you're from sir?
I am from Goa.
I see. Okay,
Madhav
sir.
Kamath.
Okay. You are a SA member of Goa Center.
Yes.
Right, sir. Thank you very much, sir. Thank you for your participation. And a question is there from PV and Gopal Rao. What is the need of soil cushion for soft clays, for foundations, and what is the depth of sand layer recommended for the type of soils?
Fine. This comes under a what we call a designing of a soil stratum, we are using some sort of sand cushions. Shall I answer, sir?
Yes, sir. Yes, sir. Proceed.
This is a case of designing of foundation by designing the suitable soil system or the soil stratification. The concept is similar to a CNS layer concept in the black cotton soils. For the ordinary cases, like in a normal case, we generally want to have the higher bearing capacity. The higher bearing capacity, once we can have the much more the economy in the foundation system is there, and also the settlements that was there will be minimum, and also we are increasing the strength point of view. And there is possibility of the combined footings also can be eliminated as the requirement of the raft is constrained. For that case, generally what we are using is we are supplementing a sand cushion to up to a certain depth that is below the bottom of the footing to extending it to the top of the by removal and the replacement with existing virgin soil. In that case, we have to compute the system like a two-layer soil system. For that, we have to compute again the strength aspect also, that is what is the your shear strength of the soil and also the settlements. But with the different trial and error methods of putting some per meter, 2 meter, that is 1B, 0.5B, 1.5B, or 2B, where B is the width of the footing. You have to consider the sand cushion thickness in terms of 0.5B, 1B, 1.5B, 2B. To a optimum value, we have to find out the bearing capacities in the settlements. And based upon the Mayrhoff's analysis, you have to determine again the safe bearing capacity and the safe bearing pressure. What is the value which is economical and also the used to your loading requirement and also the foundation requirement, that is to be appropriately chosen based upon other conditions also, like economic. And there are some research papers are there pertaining to this question also. You can obtain from the net itself. They had done the Strangler, I think one paper is there. You have the variation of this 0.5B, 0.25B, 1B, and 1.5B, 2B. This variation is nothing but you are increasing the depth of the sand cushion or the sand zone, whereby you are transmitting your shear stresses to the maximum in the soil, to a stronger soil and compared to weak soil, thereby your shear resistance and your bearing capacities were much more refined. It's a two layers, comes under the two layers soil system, and the settlements are also will be much more less when compared to maybe within the permissible limits also.
Sir, I have one question. What is the effect of liquefaction for Kakinada soils? When I attended one webinar, there our great geotech man, Dr. M.R. Madhav, has given his lecture.
Mm-hmm.
And I asked a question about the liquefaction effect for Kakinada soils. He told that for zone 3, earthquake zone 3, the effect of liquefaction is negligible and you can forget. But when I have gone through the literature, I never found that it is negligible for zone 3. What is your opinion on this?
Fine, sir. Before I will answer in it this question in two folds. Before the 2006 version of IS 1893, we have that is a code of practice for the design of seismic resistant buildings. There is no specific approach. Only it is entirely based upon the research findings of any research papers and all that. After 2016 version, there is a clear-cut procedure that was prescribed by the code, that is 1893-2016 in the annexure. There is a method called cyclic stress ratio that defines your liquefaction potential of the soil mass, that is especially in the case of sands and silty sands that is below the water table, where we are expected to the probability of any liquefaction is there. And general thinking is that soils are structures which is under zone 3 in a moderate zone, that is will not have that much of severe effect. Then the severe effect will be generally for the zone 4 or the zone 5 soils, and for zone 3 it's a mandatory for the departmental buildings, and for the private buildings we have an option there. For zone 2 generally we don't bother about. And especially while conducting the soil investigation boreholes, once the building is intended for to design for the seismic resistance point of view also, we have to cater for the seismic behavior. Not only we have a sophistication like uh, dynamic soil bearing capacities are there. If the structures are any retaining walls are there, we have the dynamic lateral pressure is to be arrived, and also the liquefaction potential of the soil is to also be arrived. And the problem entirely tunes with the your system requirement. That is whether you are opting for the in the zone two, zone three for the seismic resistant point of view. Zone 3, we can't say simply based upon the, it's not required. The loading intensity is different. So 0.160 is the generally the acceleration value we are considering for zone 3, and 0.24 and 0.36 for zone 4 and zone 5. That shaking intensity is varying. That is one of the controlling parameters in affecting the liquefaction potential of the soil. It's a site specific, just now I told to Dr. Subbaru sir also, it is a site specific criteria. For each site, being important structure, we have to do the site specific, not only the seismic point of view, for static loads also, we have to do the site specific stratification and site specific the soil design parameters. That is most important. And once we are aiming for the seismic resistant design, definitely you should address the these Kakinada soils for the liquefaction potential. General classification is the shaking intensity is not that much. That minimizes the your liquefaction potential. In that matter, we can say as a in a broad sense.
Yeah, thank you. You are also coinciding with my opinion. For zone 3 also, we have to consider the liquefaction effect, because the soils where the N values are very low, there is every possibility for liquefaction. So that aspect is to be considered. But no literature supports that for zone 3 you can neglect.
Yeah, that's true, sir. But in some Kakinada, some of the areas we have, just now I told you, there are peculiar variations there. Like in loose sands are also there.
Yeah.
Like while doing the soil investigation, recently we are going to construct one large Shivalayam to the endowment department of government of Andhra Pradesh. In that, what we found is the soil is very loose sand, having n value of 6 itself. And there is no improvement. The peculiarity of sands is that with going depth, there is a definitely improvement of the your modulus of velocity, and you have the increase in the n values. That is a density point of view. Also, you have the extraordinary variations there. It will change its state to at least from loose to medium dense, or from medium dense to dense. That case also we have observed. Like from the, with the, that is a peculiarity, and the one of the characteristic condition are the behavioral changes in the densification of the soils is considered. That is during the formation and during the testing also, that we can observe the sand variation of the N values. But in a particular site, just now I have mentioned, we have peculiarity of N value is almost constant, just like place. It is constant throughout the depth of 7 meters is the depth of the sand zone is there, existence. In this 7 meters, there is no variation in the N value. That is one of the peculiarities. Once we consider the N value of 7, it comes under loose sand side. Then from 4 to 7, sorry, 4 to 10. Loose sands are highly sensitive question. That's why I'm saying the site-specific criterion is always adopted. Generally, for the design spectrum also, while designing the earthquake resistant designs, for important structures like power plant structures also, we go with the site-specific spectrum, response spectrum. That gives a more elastic value and a in situ value that is more dependent upon the soil conditions and the actual conditions of the soil. The similar case also we are adopting for designing a modulus of what we call a quotient of elastic uniform compression, CU value for a dynamic soil parameter for design of machine foundations also. That should be also a site specific criteria.
Thank you.
Yes, sir. Sir, there is question from P.V. Venugopal Rao. Please clarify 3B means in the preservable diagram. The column load considered is 10% multiplied by load of column P. Please clarify.
3B, you are asking 3B significance.
Yes, sir. He wrote that.
Fine.
3B, what is, what is 3B in the preservable diagram?
Fine, sir. Regarding the bulb of pressure concept is considered, these are nothing but the stresses that is distributing into the soil mass. That was actually based upon the research work of Burmester and Westergaard. All the research works are based upon that in a similar fashion. Uh, the importance is that we have to consider the stresses in various layers of the soil that is going to the depth. That is the main significance. That is the stress increment delta J that strains the material. That is the stress corresponding to the strain. That is our importance. We require the delta sigma j at a particular level or particular layer of existence. We have stratified soil is there or uniform soil is there. In that, at a particular depth, the stress is there. Once we look at into the stress bulk for a uniform homogeneous soil deposit, the stress bulk will be significant. That is, the diminishing of the stresses below the bottom of the footing. Generally, at the bottom of the footing, you have the stress that is equal to the contact stress, that is the bearing pressure. That will decrease when you go into the depth. The depth variation is there within the soil mart. That significant depth we generally treated as 1.5B to 2B. Up to 2B, you have the 70% distribution is there. Beyond 2B, you have only 30% is there. That is, suppose you are designing the foundation as a 10 tons per meter square allowable bearing pressure. The stress below the bottom of the footing is 10 tons per meter square, and it is distributing to the soil mass. Up to 2B, you have the 70%, that is 0.7 times of 10. That is beyond the 2B, you have 3 tons per stress intensity is there. Once you go beyond the 2B depth also, there is a stress distribution there. But total distribution, zero distribution, it will be taken up to an infinite depth. 3B also we have at least some 20%. 10%. 10% is 4B. Up to 4B, have 10%. And the variation is not significant. And once you can compute the settlements also, that will be reflected in settlement equation calculations. But beyond 2B, it's not practically, also it is not suggestible. And also for theoretical point of view, also up to 2B, 70% is there. 4B, you have 10%. For the infinite extent, it will almost have the influence. In most of the cases, 2B or 20B also, you have the influence. It's only the significance value we are taking, sir. 4B generally it is not required for the design point of view, for any computational settlement point of view.
One more question from Aditya Kumar, sir.
Tell me, sir.
How do we the settlement of a particular area? If the settlements of soil is high, what we should do?
Yeah. Can you repeat once again, sir? Question, please.
Yes, sir. How do we settlement of a particular area? If the settlement of soil is high, what we should do?
Fine. Regarding this, it's a somewhat a generalized question and also a site-specific question. First of all, the settlement is one of the important criterion. For that, we have to conduct the geotechnical investigation. Hello. We have to conduct the geotechnical investigation. Based upon that, we know that soil stratum, that is the variance of different type of soils, to the depth of variance. And also based upon the laboratory testing, we'll know your design soil parameters. These design soil parameters are nothing but, in the case of clays, you have the CU values required. In the case of sand, the angle of internal resistance or shearing resistance, 5 values required. Besides that, you require your unit weight of the soil, and also you require especially you want to have the sensitive analysis, like we require the one-dimensional consolidation test value, that is the odometer modulus, E modulus is required. Or otherwise, for a simple case or a less important building, you can adapt from based on the Skelton's equation that was also prescribed in the code, that is in IS 8009. The point 009 into liquid limit minus 20, that is gives your CC value. That is CC value is the governing value that governs the compressibility of the soil, especially in the case of clay. What you require is you require what is the stratification of the soil, different types of soils, and you require what is the depth of existence, and also you require both strength and the soil settlement characteristics. Strength characteristics are nothing but phi value and a gamma value, that is the unit weight, and you require the Cu value in the case of a clay soil subconstruct. And the other factors that is required is the initial void ratio that can be applied from a ELOG plot that is obtained from the odometer test or the consolidation test. The other important factor is also CC value that represents the compressibility, or you can have alternatively MV values. These using these values, we have to put it into the one-dimensional consolidation theory for the case of the clay soils based upon the your wall button pressure of the corresponding middle of the layer, and also the stress that is coming due to the application of the your bearing pressure or contact stress at the bottom of the footing. For that, you require what you require is the stresses is to be computed based upon any standard theories of like Boussner's or any like 2:1 method. Different methods are there. Using that method, you can compute the settlement corresponding to a layer mid depth, and we have to corresponding the settlement is to be applied. And once you find out the settlement of the different layers, but simply summation of all those settlements, we will get the total settlement, which is under the influence depth. That is the influence depth is 2B. 1B, 1.5B also is convenient, but to the sensitive value 2B is required. And once the settlements are not meeting the standard settlement criterion prescribed by the code in IS 1904 or as per any standard literature like McDonald and Scatworth in 1966 work, you have to think of in terms of two alternatives, whether you are going with a shallow foundation or a deep foundation. If you are affordable and capable of doing the deep foundation is the best. Why? Because the settlements are controlled. The permissible settlements for the single pile is 12 mm, and for in a group it is 25 mm. Even though costly, the settlements, if the structure is settlement sensitive, like radar foundations or the transmission line tower foundations are that, you have the settlement restrictions are there. In that case, the only and the alternative is generally pile foundation. And if you want to have the economy in the structure, then you have the alternative in terms of various ground improvement techniques also. Like these government techniques, you can have the pre-consolidation settlements, and also you can have the restrict the settlements by adopting suitable tech ground implements like stone columns. We have granular pile anchors are there. Like in modern day methods, like we have using the engineering with the geosynthetics. All these methods are pertinent to not only for the bearing capacity improvement point of view, also to minimize the settlements also.
Yes, sir. Mr. Ravi Babu texted that. Thank you very much to Dr. Narasimha for your wonderful presentation.
Thank you, sir.
Kindly share PPT in the group. He is requesting to share PPT, sir.
Right, sir. Thank you. Definitely. One more thing. Hello.
Yes, sir. Tell me, sir.
At the outset, I would like to thank Engineer Badal Sundar Garu and other colleagues of the AS group, and also the host group of the AS, and also especially Badal Sundar Garu and L.S. Subramanian Garu, who encouraged me in delivering my today's lecture. If any doubts are there, I will share my email ID also. The copy of the today's presentation is available with Sundar Garu. If anyone was interested, I have no objection in supplying the same. Thank you very much. Thanks for your patience.
I'll share that in the group tomorrow.
Yes, sir.
Okay, sir. Thank you, Dr. Rao, for your elaborate and detailed lecture. It is a refresher course. It's very excellent, sir. Your knowledge is very helpful for all of us, and we are highly thankful to you, sir. Now I request Durga Prasad Garu to say vote of thanks and close the session, sir.
Yes, sir. Thank you, Narasimha Garu, for your valuable time and presentation, sir.
Thank you, sir. Thank you very much.
Thank you to all of our ACCA members for your valuable participation. Thank you very much. Thank you, sir. Thank you.
థ్యాంక్స్ అండ్ సుందర గారు మీ దీనివల్ల చెప్పాను అదే పవర్ తీసేస్తున్నారు సార్ అదొకటి మెయిన్ ఇది మీ ఆఫీస్ బాగా ఉపయోగపడింది మాకు సైక్లిక్ సస్టేషన్ చెప్తాను సార్ లెక్చర్ చెప్తాను